We'll talk about Stuart Russell's book, the AI solution in his book, Human Compatible. And the caveat I want to put here is that I'm focusing on the solution, so this isn't a book summary. And I did find the whole book enlightening and impactful, but what happened is a bunch of ideas that kind of came to mind as I was going through the book, and I've kind of put them together here for us. And Stuart starts with the idea that we have to design machines with a high degree of intelligence. And in a nutshell, what he's talking about in terms of a high degree of intelligence is the ability to deal with a complex world. And this is very important. And so one of the first things that we want to look at is that we're focusing on intelligence and not consciousness. So we're not talking about a machine that can get its own consciousness. And Max Tegmark tells us that we can control lions because we're more intelligent, not because we're more conscious. So there's a link between intelligence and consciousness. With Stuart, what he goes on to is basically he talks to us about narrow AI, where we really need few talents, and that's really what has happened to us in our present world. Is that we've built a world around the fact that we've had many talents, and now we've gone down to where we only need few talents. But the idea of having narrow AI and few talents means that we could actually bundle it, and we could actually kind of put the objective into control. However, with general AI, it's really something that is different, because with general AI, what we're talking about is we're talking about this AI, this intelligence that has the capability to live in the real world with all the kind of unusual things that happen in the real world, whether it be an assistant robot or the interconnected systems. We're really talking about, its ability to deal in the multi-world, I call it, the multi-dimensions, multi-dependencies, multi-emergencies, and the unpredictable things. And it has to be able to deal with multi-variables, which we really need a quantum computer in order to do. The solution characteristics of it are, it's what works. It works on the I can be wrong, feedback loops, and uncertainty. So you're not trying to do a damn torpedoes full speed ahead type of solution. The idea, it kind of goes counter to what I believe, Steve Jobs was talking about when he says that our goal was to kind of put a dent in the universe. I don't think that that's really where we're going here. What we need to do is what do we really need to have control over? And if we take Maslow's hierarchy of needs and we look at the hierarchy of needs, we really want to say that we want the humans to basically be able to control the self-actualization, the esteem, and the love and the belonging part of the needs. And why not have the technology control the safety and the physiological side? So can we, in a general AI, if we're asking for it to look the way he's interested in having it manage our preferences, and it can do it for the single individual, the good of the one, but it has to marry that also against the good of the many. This is one of the things that he talks about in there. It gets us to the idea that Spock talks about is the good of the many outweighs the good of the one or the good of the few. The problem is that the good of the many is probably the most significant concept. But it also, when I was reading Russell, it kind of gets a miracle occurs here concept to it, the way he addresses it. And I think that if we look at the good of the many as just that's the two sides of the needs, we actually have something that's a little bit different. And one of the focuses that Russell has is we have to start making the machine humble, or teach the machine how to be humble. And it kind of runs counter to what Harari says, which is saying that we really have to try and make man be a little more humble. So the second big piece is that he wants to make sure that we ensure that those machines never behave in ways that make us seriously unhappy. So that's the next thing. And kind of in a nutshell, what does he mean by that? Is he says that we're going to look at this inverse reinforcement learning. So we're going to provide objective behaviors and let it basically learn from those behaviors, from our behaviors. And so what he's talking about is the behaviors that are being provided for this learning are he's going to preferences that he's going to learn from our behaviors. So that the machine is going to learn from our behaviors. So it's going to kind of study our behaviors, and from that it's going to decide. So it's going to look at our artifacts, our movies, and everything else, and our basically existing kind of corporations and myths and things like that, and the way people are acting today. And those are the things that it's going to do in order to capture those behaviors, in order to determine what it is that our preferences are. The challenge that we have is that our behaviors are, there's kind of the idea that our behaviors are rational is really kind of a male con. We're really not not a rational species. And as Habermas talks about the components of rational decisions, that we don't really have those and have them under control. And so what do we really bring to the table here? Okay, we are an insecure and a cruel species. We got to the top too fast. The problems that we're talking about are too complex for our species. Our brain advantage is narrating, so we kind of are liars, and our misadvantage is the male view, so it's paternalistic. So we have all these biases. There's these paternalistic biases and other biases in our whole view. So when if you're going to try to look at our behaviors and extract some kind of knowledge from our behaviors, and if you look at the idea that knowledge, it basically gets from information, it's on the other side of a wall from information, and it has to work through our biases, which are complicated by things like groupthink and also the way that we can be diverted into different things. And so if you look at this kind of spectrum that we always talk about, where data becomes information, information becomes knowledge, again, it's another challenging area because we're just not good at it. And so if you're going to say you're going to take our behaviors and we're going to use our behaviors and look at our artifacts and get our preferences from that, and that's what you're going to use to help formulate what it is that the technology is going to do, that's really a bit of a challenge. And now, Pinker, on the other side, is saying that our preferences are changing. And so we're actually on the dawn of a kind of a whole new book on human behaviors guide. And so that looking at the old behaviors is not necessarily valuable. So Pinker challenges that too, I believe, all right? And then the other thing he talks about now is the idea of computed, and this is where he says that all of what we want with this technology is to build it on this concept of utility. But utility maximizes both things like minimizing cost and reward maximization and loss minimization. And again, if we get back to what Habermas told us, is that the idea of cost, efficiency, and performance run up against the ceiling with regards to man, because they really ignore the idea of human resonance, of care in the whole package. And so all of our institutions and everything that we have today are stuck on that. So the real challenge is, how can we add care to the algorithm that we want to use for these technologies? And my suggestion is that we might want to add something like reducing brutality, add that to care and add that into the algorithm. And so that we won't have an algorithm that's just based upon those minimization and maximization concepts, but also using care as a factor. Thank you.